Hello all. We learn virtual learning network. Business mathematics session number 2, limits. Topic to be covered in this session: define limits or what is the limits, linear functions and their applications, limits of function, one side limits and its continuity. So, limit. This table, see the table before the definition of the limit. This table shows that function of x is doing as x approaches to, or we have the limit of the function as x approaches to. We have written this procedure with the following notation, like limit x tends to 2, 2x minus 1 equal to 3. Definition we write as limit x tends to c, function of x equal to L, or as x tends to c, then functions of x equal to L. Consider the function x square minus 1 divided by x square plus 2x minus 3. See what happens as x approaches 1. This function approaches 0.5 as x approaches, like given in the tables. Like 0.5, the value of function is 0.43. If we put 0.9 in place of x, then the value of function 0.487, 0.99 equal to 0.499, and 0.999, the value of function is 0.4999. If we have put the value 1, then nothing should be recovered. Then the value of 1.001, then 0.5000, and so on. The left hand side limits is known as left hand side limit or approaches 1, and the right hand side limits is approaches of right hand sides. So we can also prepare a graph by using this identities. So limit x square minus 1 upon x square plus 2x minus 3 equal to 0.5. Limits if function of x gets closer and closer to a number L as x gets closer and closer to c from both sides, then L is the limit of a function of x as x approaches c. The behavior is expressed by writing limit x tends to b power c fx equal to L. From above two examples, we know number c that x approaches may or may not be in the domain f. It is important to remember that limits describe the behavior of a function near a particular point, not necessarily at the point itself. There are three types of function which is specifying here, like figure A, the point is middle, the figure B, the point is above the line, and figure C, the point is below the line. So three functions for which limit x tends to c, function of x equal to 4. So we can represent the various formats of the function or limits, like if limit x tends to c, function of x, and limit x tends to c, function of gx, exit. If limit x tends to c, then function of x plus function of gx equal to limit x tends to c, function of x plus limit x tends to c, function of gx. That is known as plus sum. Then minus sum, if we minus both the functions to each other, then limit x tends to c fx minus limit x tends to c gx. Limit x tends to c k function of x equal to k limit x tends to c fx for any constant or any value of k. This is also called times multiplicity or multiply constant. Limit x tends to c function of x multiply function of gx equal to limit x tends to c function of x bracket close then bracket start limit x tends to c gx bracket close. That is the product of two different limit functions. So division or quotient function of limit x tends to c function of x upon function of g equal to limit x tends to c fx upon limit x tends to c gx. If limit x tends to c gx does not equal to 0, that is quotient dividend by powers. For any constant k, limit x tends to c k equal to k and limit x tends to c x equal to c. And now we can write this kinds of the form like limit x tends to minus 2 3x square plus 5x minus 9 is also written as limit x tends to minus 2 3x square plus limit x tends to minus 2 5x minus limit x tends to minus 2 9. It is known as polynomial coefficient, which is equal to 3 limit x square plus x tends to minus 2 5 limit x minus x tends to minus 2 9 arithmetic. Then 3 minus 2 का square plus 5 minus 2 minus 9 which is equal to minus 31. Limit x z tends to 1 6 minus 3z plus 10z square divided by minus 2z4 plus 7z cube plus 1 equal to limit z tends to 1 6 minus 3z plus 10z square divided by limit z tends to 1 2 minus 2z4 plus 7z cube plus 1. It is a rational function of the limits. The value of it, this one 6 minus 3 1 plus 10 1 square divided by minus 2 1 की power 4 plus 7 1 का cube plus 1 which is equal to 13 by 6. From above example we can see that for a polynomial function limit x tends to c px equal to pc, and if px and qx are both polynomials then limit x tends to c px upon qx equal to pc upon qc if qc does not equal to 0. Evaluate the following limits. Example, limit x tends to 2 x square plus 4x minus 12 upon x square minus 2x. And now putting the value of x in place of this one, and that is calculated as 0. Limit x square plus 4x minus 12 upon x square minus 2x equal to, if we factorize the function, x minus 2 x plus 6 upon x common x minus 2. So x minus 2 cancelled by x minus 2. Then it becomes limit x tends to 2 x plus 6 divided by 2, and putting the value of x in place, putting the value of 2 in place of x, then limit 2 plus 6 divided by 2, so 8 by 2 which is equal to 4. Intermediate form, if limit x tends to c fx equal to 0 and limit x tends to c gf equal to 0, then limit x tends to c function of x upon function of g is said to be indeterminate forms. The term indeterminate is used because the limit may or may not exist. For example, limit t tends to b power 4 t minus root 3t plus 4 divided by 4 minus t. So, limit t tends to 4 t minus root 3t plus 4 multiply by the conjugate of numerators, that is t plus root 3t plus 4 divided by 4 minus t plus root 3t plus 4. By using the formula a square minus b square, so a plus b, a minus b. It is equal to t square minus 3t plus 4 upon 4 minus t plus root 3t plus 4. Then factorizing it, the functions or numerator, that become t minus 4 and t plus 1 divided by 4 minus t plus root 3t plus 4. 4 minus t cancel out by t minus 4. So it becomes t, limit t tends to 4 equal to t plus 1 divided by minus t plus root 3t plus 4, which is putting the value of t, that means putting the 4 in place of t. So the value of numerator is 5 and the value of denominator is 8. So the final answer of this example equal to minus 5 by 8. We can also discussion by using another formula like this: x upon x tends to 0, x upon root 1 plus x minus root 1 minus x. So once again we have multiply the conjugate of numerator. So x root 1 plus root 1 minus x divided by root 1 minus x minus root 1 minus x multiply root 1 plus x plus root 1 minus x, and by using the formula a plus b and a minus b equal to a square minus b square. So we get limit x tends to 0 x root 1 plus root 1 minus x divided by 1 plus x minus 1 minus x. So limit x tends to 0 x root 1 plus root 1 minus x divided by 2x, which is equal to limit x tends to 0 root 1 plus 1 minus x upon 2, which is equal to 1, and the value of entire the question equal to 1. Limits at infinity, limits at infinity if the value of the function f(x) approach the number of L as x increase without bound. That means there is no limit of the function of x. We write limit x tends to infinity function of x equal to L. Limit x tends to infinity fx equal to m when the functional value fx approach the number m as x decreases without bound. So it can be solved by an example like the function coverage to a single value 1. We write limit x tends to infinity function of x equal to 1 like given in the figures. So another example, the function can converge to a single value 0, the limit of f, we write x tends to infinity function of x equal to 0 if there is no change in the line of the limits. The examples, another example, the function can do all this either at plus infinity or minus infinity. The function's convergence at minus infinity and diverges at plus infinity we can write as limit x tends to plus infinity function of x equal to positive infinity, and limit x tends to minus infinity function of x equal to 0. So computing limits at infinity, reciprocal power rules for constant a and k with k greater than 0, limit x tends to plus infinity a upon x की power k which is equal to 0, and limits a upon limits x tends to minus infinity a upon x की power k is also 0. And now question, limit 2x cube plus 5x square minus x plus 1 upon x cube plus 1 cube squares. So, solution by making it cubic function, rewrite as 2x cube plus 5x square minus x plus 1 upon x cube plus 1. 2 plus 5 by x minus 1 by x square plus 1 by x cube. That means dividing whole the equations by x cube. So, denominator becomes 1 plus 1 upon x cube. Substitute x equal to infinity to conclude 2 plus 5 by x minus 1 by x square plus 1 by x cube divided by 1 plus 1 by x cube. This equal to 2. After substitution x equal to infinity, all the circles terms become 0 and the value will be 1 or 2. Exercise. Next, limit x tends to infinity 2x4 minus x square plus 8x divided by minus 5x की power 4 plus 7. Procedure for evaluating a limit at infinity of fx equal to px divided by qx. Step 1. Divide each term in fx by the highest power hk that appears in the denominator polynomials qx. Like for example, the highest power of this example is x की power 4. So you divide all the equations by x की power 4. Compute the limits x tends to infinity fx or limit x minus infinity fx using algebraic properties of limits and the reciprocal power rules. So solution, we have taken or divide the equations, divide the numbers by x की power 4. So 2 minus 1 upon x square plus 8 upon x cube divided by minus 5 plus 7 by x4. So limit x tends to the power infinity 2 minus 0 plus 0 divided by minus 5 plus 0. So the value will become minus 2 by 5. Definition, we say that limit x tends to c, function of x is an infinite function of x is an infinite limits if fx increases or decreases without bound as x tends to c. Limit x tends to c, function of x equal to positive infinity, and limit x tends to c, function of x equal to negative infinity. So, limit x tends to 3, 2x upon x minus 3 equal to positive infinity. Limit x tends to minus 3 equal to 2x upon x minus 3 equal to minus infinity. One side limit and continuity. If a function of x approaches k as x tends towards c from the left x less than c, then we write limit x tends to c, function of x equal to k, and call k the limits from the left or left hand limits. If function of x approaches L as x tends toward c from the right, then c greater than x, we write limit x tends to c, function of x equal to L, and call L the limits from the right or right hand limits. Existence of a limit, we have a left side limit x tends to c, function of x equal to k, and a right side limits limit x tends to c positive, function of x equal to L. So, to say a limit of function of x exists, the limit from the left and the limit from the right of function of x must exist and be equal. Existence of a limit like the figures, limit x tends to the power minus 1, function of x equal to 0, left hand limits, limit x tends to the power 1, function of x equal to 1, right hand limits, and function 1 equal to 1, value of the functions. So, limit x tends to 1, function of x does not exist because the left and right hands limit do not match. And for this function at x equal to 3, limit x tends to be power minus 3 fx equal to t left hand limits. Then limit x tends to be power positive 3 fx equal to 2 right hand limits. Then function of 3 equal to 2 value of this function. So limit x tends to be power 3 function of x equal to 2 exists because the left and right hand limits match. And now continuity. A continuous function is one whose graphs can be drawn without the pen leaving the paper, no holes or gaps. Continuity, a hole at x equal to c, see the figures. Then continuity, a gap at x equal to c. And definition, a function f is continuous at c if all three of these conditions are satisfied. Number 1, if function of c is defined. Number 2, limit x tends to be power x tends to be c, function of x exists. And number 3, limit x tends to c, function of x equal to function of c. So fx is continuous at x equal to 3 because the left and right limits exist and equal to f3 from the figures. So at x equal to 1, limit x tends to be power 1 positive does not equal to x to be power negative fx. So discontinuous at x equal to 1. At x equal to 2, if x tends to be positive 2, function of x equal to limit x tends to be power minus 2, function of x does not equal to f2. And same as limit x tends to be power 3, limit x tends to be positive 3 fx equal to x, limit x tends to be minus 3 fx equal to f3. So it is a continuous function. Continuity of polynomial and rational function. If px and qx are both polynomials, then limit x tends to be power x tends to be c px equal to pc. Limit x tends to c px upon qx equal to pc upon qc. If qc does not equal to 0, a polynomial or a rational function is continuous wherever it is defined. So continuity of polynomials and rational function. Determine where the function below is not continuous. For example, ht equal to 4t plus 10 divided by t square minus 2t minus 15. So rational functions are continuous everywhere except where we have division by 0. So t square minus 2t minus 15, factorize it, and the factors of the equation is t minus 5 and t plus 3 equal to 0. So the value of the function is t equal to minus 3 and t equal to 5. Discuss the continuity of each of the following functions like fx equal to 1 by x and gx equal to x square minus 1 upon x plus 1 and hx equal to x plus 1 if x less than 1 and 2 minus x if x greater than equal to 1. For what value of the constant is the following function continuous for all real x? And the question is the function of x equal to ax plus 5 if x less than 1 and x minus 3x plus 4 if x greater than equal to 1. So limit x tends to be minus 1 fx equal to limit x tends to be plus 1 fx equal to f1. So limit x to the power minus 1 a plus 5 equal to limit x plus 1 x square minus 3x plus 4 equal to f1. So a plus 5 equal to 2 and a equal to minus 3. Another example, same, and do it. Find the number a and b so that the following function is continuous everywhere. Fx equal to ax, x square plus a minus b and bx. The condition is that for first condition x less than equal to minus 1, if minus 1 less than equal to x less than 1 and if 1 less than equal to x. Since the parts of f are polynomials, we only need to choose a and b so that f is continuous at x equal to minus 1 and 1. So limit x tends to power minus 1 fx equal to limit x tends to power minus 1 fx equal to f minus 1 So limit x tends to power minus 1 x square plus a minus b, limit x tends to power 1 equal to x square plus a minus b. So limit x tends to power plus 1 bx minus a equal to 1 plus a minus b. So 2a minus 2a plus b equal to 1. And therefore we have obtained two equations, minus 2a plus b equal to 1 and 2a minus 4b equal to minus 2. So by cancellation of a, then minus 3b equal to minus 1 and b equal to 1 by 3. A minus 2 by 3, putting the value of b in equation number 1, then a minus 2 by 3 equal to minus 1, then a equal to minus 1 by 3. So fx equal to minus x by 3 if x less than minus 1, x square minus 2 by 3 if minus 1 less than equal to x less than 1, and x by 3 if 1 less than equal to x. And now continuity on intervals. A function fx is said to be continuous on an open intervals a less than x less than b if it is continuous at each point x equal to c in that intervals. F is a continuous on closed interval a less than equal to x less than equal to b if it continuous on the open interval a less than x less than b, and limit x tends to a fx equal to fa, limit x tends to minus b fx equal to b. So function of x equal to root 1 minus x square is continuous on 0 or 1, open interval a and b, end point, closed interval a and b. Intermediate value property. Suppose that fx is a continuous on a and b and let m be any number between fa and fb. Then there exists a number c such that 1 into a less than c less than b and 2 function of c equal to m given in the picture. So intermediate value property, corollary, if f is a continuous on ab and if a function of a and function of b have opposite signs, then there exists a number c in a and b where fc equal to 0, like the figures. Example, show that the equation x square minus x minus 1 equal to 1 upon x plus 1 has a solution for x 1 less than x less than 2. Fx equal to x square minus x minus 1 upon x plus 1, then minus 3 by 2 for f equal to 1 less than 0 less than 2 equal to 2 by 3. There is a number c such that 1 less than c less than 2 and fc equal to 0. So explain the concept of linear function as per the discussion and their application, and what do you mean by limits of functions. That's from the session number 2 of business mathematics.